Hello everyone, I am Purnima AM. I am a second year student of CS department, PS ITM Shimoga. Today I am going to explain you about memory system, basic concept of memory system and its considerations. Computer organization deals with the different functional units of the computer and how they are interfaced, their components, functionalities, implementations and their optimizations. The programs and the data on which they operate are kept in the memory for execution. These are be transferred between the memory and the processor. That the memory system is interfaced with the processor. In the past, the processor was slow, so the memory system could cope up with that. But as time passed by the processor, speed evolved much about up to million instructions per second. But the memory is not capable to provide that much instructions per second. The performance of the whole system is not only dependent on the execution speed of the processor but also the speed with which the instructions and data can be transferred between the memory and the processor. So we need our memory to be fast. But if we go for a fast memory, cost will be high and hence we cannot have large enough memory, but we need large memory too. To keep large quantity of data, that the memory should be large fast and at the same time it should be cost effective. In this video, we should deal with the basic concept of memory system considerations, use of memory controller and memory read, memory write. This is all about the introduction part. Next we move on to the basic concepts of memory system. Memory consists of millions of storage cells which can store a bit of information having the value 1 or 0. The memory is organized such that a group of n bits referred as word can be stored or retrieved in a single basic operation. A unit of 8 bits named as 1 byte. A unit of 8 bits form 1 byte. If the word length number of bits in a word of a computer is 32, then the word can store 4 bytes of information. Each byte. 1 byte means 8 bits of information. Each byte in a memory is assigned a distinct address. Smallest memory unit that can be addressed is byte. It is a known as byte addressable memory. Byte addressable memory means each byte in a memory is assigned a distinct address. The maximum size of the memory that can be used in any computer is determined by the addressing scheme. Consider the example. If the maximum or total capacity of the memory is 2 raised to 16 or 64 KB, we need minimum of 16 address information need to uniquely address each of the byte present in the memory. Similarly, our memory is of size 4 GB means 2 raised to 32 size. In such situation, we need a minimum of 32 bits of address bits needed to uniquely address each of the byte present in the memory system. Similarly, suppose capacity of the available memory is 1 TB, that is 2 raised to 40, then we require a 40 bits of address information needed to uniquely address each of the byte present in the memory. Most modern computers are byte addressable. Byte locations have addresses 0, 1, 2, 3, 4 up to 2k-1. For a 32-bit computer means word length equals 32 bits. Each word is assigned the addresses 0, 4, 8, etc. There are two ways that the byte addresses can be assigned across a word: Big Indian method and Little Indian. Big Indian arrangement is used in the 68000 processor. The Little Indian arrangement is followed in the Intel processors. ARM architecture can be configured to use either arrangement. Connection of memory to the processor. Data transfer between the memory and the processor. takes place through the use of two processor registers MAR MDR. MAR means memory address registers, MDR means memory data register. If MAR is k bits long and MDR is n bits long, then the memory may contain up to 2 power k addressable locations and n bits of data are transferred between the memory and the processor. During a memory cycle, n bits of data are transferred between the memory and the processor. This transfer takes place over the processor bus. The processor bus has address line, data line, control line, read or write operation MFC. MFC means memory function completed. The control line is used for coordinating the data transfer. Memory read and memory write. The processor reads the data from the memory by loading the address of the required memory location into MAR and setting the read or write bar line to 1. Memory responds by placing the data from the addressed location onto the data lines and confirms this action by asserting MFC signal. Upon receipt of MFC signal, the processor loads the data in the data lines into MDR register. Next, memory write. The processor writes the data into the memory location by loading the address of the memory location into MAR and the data into MDR and setting the read or write bar line to 0. The memory responds by placing the data from the data lines onto the addressed locations and confirms this action by asserting MFC signal. Speed of memory units. They are memory access time and memory cycle time. In memory access time, it is the time that elapses between the initiation of a memory operation and the completion of that operation. Time between the read and MFC signal. It is the time that elapses between the initiation of a memory operation and completion of that operation. Access time is the amount of time it takes the processor to read data, instructions, and other information from the memory. A computer's access time directly affects how fast the computer processes data. Memory cycle time. It is the minimum time delay that required between the initiation of two successive memory operations. Time between two successive read signal. Cycle time is the time, usually measured in nanoseconds, between the start of one random access memory, means RAM, access to the time when the next access can be started. Cycle time consists of latency, the overhead of finding the right place for the memory access and preparing to access it, and transfer time. System considerations. The choice of RAM, the random access memory. RAM chip for the given application depends on several factors. They are cost, speed, power dissipation, and size of the chip. SRAM means static random access memory. SRAM is only used when very fast operation is the primary requirement. Their cost and size are adversely affected by the complexity of the circuit that realizes the basic cells. They are used mainly in cache memories. DRAM. DRAM means dynamic random access memory. DRAM are the predominant choice for implementing computer main memories. The high densities achievable in these chips make large memories economically feasible. This is about considerations of memory system. Memory controller. To reduce number of pins, the DRAM chips use multiplexed address inputs. The typical processor issues all bits of an address at the same time. The required multiplexing of address bits is usually performed by a memory controller circuit, which is interposed between the processor and the DRAM. DRAM means dynamic random access memory. The multiplexing of address bit is usually done by memory controller circuit. The controller accepts a complete address and read or write bar signal from the processor under the control of a request signal which indicate that a memory access operation is needed. The controller then forwards the row and column portions of the address to the memory generates RAS and CAS signals. It also sends read or write bar and CS signals to the memory. While using DRAM, while using DRAM chips which do not have self-refreshing capability, the memory controller has to provide all the information needed to the control the refreshing process. This is the explanation of the memory controller. In this video, I am going to share you the bonus topics which is related to the memory systems. Rhombus memory. A very wide bus is expensive and requires a lot of space on the motherboard. Alternative approach is to implement a narrow bus that is much faster. This bus is called as the Rambus. Key feature is the fast signaling method used to transfer information between chips. It allows a clock frequency of 400 MHz. These chips use cell array based on DRAM technologies. Multiple banks of cell arrays used to access more than one word at a time. Original design of Rambus is to provide 9 data lines and number of control and power supply lines. It completes directly with DDR STRAM technology. Read-only memories ROM. SRAM and STRAM chips are volatile, lose the contents when the power is turned off. Many applications need memory devices to retain contents after the power is turned off. For example, computer is turned on, the operating system must be loaded from the disk into the memory. Store instructions which would load the OS from the disk need to store these instructions so that they will not be lost after the power is turned off. We need to store the instructions into non-volatile memory. Non-volatile memory is read in the same manner as volatile memory. Separate writing process is needed to place information in this memory. Normal operation involves only reading of data. This type of memory is called read-only memory or ROM. A logic value of 0 is stored when the cell is in the transistor is connected to ground at the point P, otherwise 1 is stored. The bit line is connected through a resistor to the power supply. To read the state of the cell, the word line is activated. Thus, the transistor switch is closed and the voltage on the bit line drops to near 0 if there is a connection between the transistor and ground. If there is no connection to the ground, bit line remains at the high voltage 1. A sense circuit at the end of the bit line generates the proper output value. Data are written into ROM when it is manufactured. Read-only memory. Data are written into a ROM when it is manufactured. Programmable read-only memory (PROM) allow the data to be loaded by a user. Processes of inserting the data is irreversible. Storing information specific to a user in a ROM is expensive. Providing programming capability to a user may be a better. Erasable programmable read-only memory. Store data to be erased and new data to be loaded. Flexibility useful during the development phase of digital system. Erasable reprogrammable ROM. Erasure requires exposing the ROM to UV light. Electrically erasable programmable read-only memory. To erase the contents of EEPROMs, they have to be exposed to ultraviolet light, physically removed from the circuit. EEPROMs, the contents can be stored and erased electrically. Then flash memory. Flash memory has similar approach to EEPROM. read the contents of single cell but write the contents of an entire block of cells. Flash devices have greater density, higher capacity and low storage cost per bit. Power consumption of flash memory is very low, making it attractive for use in equipment that is battery driven. Single flash chips are not sufficiently large, so large memory modules are implemented using flash cards and flash drives. Flash memory in flash memory approach is similar to EEPROM. It is based on single transistor controlled by trapped charges. In flash drives, it is possible to read contents of single cell, but it is only possible to write an entire block of cells. They have greater density, which leads to higher capacity and lower cost per bit. Lower power consumption, portability, and low cost are its advantages. Flash drives are solid state electronic devices that has no movable parts. They are intensive to vibrations. Disadvantages are their smaller capacity and higher cost per bit. It will also deteriorate after it has been written a number of times. Speed, size, and cost. A big challenge in the design of a computer system is to provide a sufficiently large memory with a reasonable speed at an affordable cost. Static RAM. It is very fast but expensive because a basic SRAM cell has a complex circuit, making it impossible to pack a large number of cells onto a single chip. Dynamic RAM. Simpler basic cell circuit, hence a much less expensive but significantly slower than SRAMs. Magnetic disk. Storage provided by DRAMs is higher than SRAMs but is still less than what is necessary. Secondary storage such as magnetic disk provide a large amount of storage but is much slower than DRAMs. Memory hierarchy. Fastest access is to the data held in processor registers. Registers are at the top of the memory hierarchy. Relatively small amount of memory that can be implemented on the processor chip. This is processor cache. Two levels of cache. Level 1 L1. Cache cache is on the processor chip. Level 2 L2. Cache is on between the main memory and processor. Next level is main memory implemented as SIMs. Much larger but much slower than cache memory. Next level is magnetic disk, huge amount of inexpensive storage. Speed of memory access is critical. The idea is to bring instructions and data that will be used in near future as close to the processor as possible. Cache memories. Processor is much faster than the main memory. As a result, the processor has to spend much of its time waiting while instructions and data are being fetched from the main memory. Major obstacle towards achieving good performance. Speed of the main memory cannot be increased beyond a certain point. Cache memory is an architectural arrangement which makes the main memory appear faster to the processor than it really is. Cache memory is based on the property of computer programs known as locality of references. Locality of reference analysis of programs indicates that many instructions in localized areas of a program are executed repeatedly during some period of time, while the others are accessed relatively less frequently. These instructions may be the ones in a loop, nested loop, or few procedures calling each other repeatedly. This is called locality of reference. Temporal locality of reference and spatial locality of reference. In temporal locality of reference, it recently executed instruction is likely to be executed again very soon. Spatial locality of reference. Instructions with addresses close to a recently instruction are likely to be executed soon. In cache memories, processor issues a read request, a block of words is transferred from a main memory to the cache, one word at a time. Subsequent references to the data in this block of words are found in the cache. At any given time, only some blocks in the main memory are held in cache. Which blocks in the main memory are in cache is determined by a mapping function. When the cache is full and a block of words needs to be transferred from main memory, some blocks of the words in the cache must be replaced. This is determined by a replacement algorithm. Cache hit. Existence of a cache is transparent to the processor. The processor issues read and write requests in the same manner. If the data is in the cache, it is called read or write hit. Read hit, the data is obtained from the cache. Write hit, cache has a replica of the contents of the main memory. Contents of the cache and the main memory may be updated simultaneously. This is the write through protocol. Update the contents of the cache and mark it as updated by setting a bit known as a dirty bit or modified bit. The contents of the main memory are updated when this block is replaced. This is write back or copy back protocol. Cache miss. If the data is not present in the cache, then a read miss or write miss occurs. Read miss. Block of words containing this requested word is transferred from the memory. After the block is transferred, the desired word is forwarded to the processor. The desired word may also be forwarded to the processor as soon as it is transferred without waiting for entire block to be transferred. This is called load through or early restart. Write miss. Write through protocol is used, then the contents of the main memory are updated directly. If write back protocol is used, the block containing the addressed word is first brought into the cache. The desired word is overwritten with the new information.